Hi and welcome back to another video. In this session we're going to be covering capacitor reactance laws. So in this example I've got a time varying voltage source with two capacitors in series. Now we have these rules. The total reactance of a circuit in series is the individual reactance added together. So exactly like resistors in parallel and series. So in parallel that means if you follow these two laws, if we take the reciprocal of each reactance and we again take the final inverse, we should get the final reactance of that circuit. So we take the reciprocal of each capacitor, we sum it all up, and we finally take the final inverse to get the final reactance. And therefore the current in the circuit we can say is the voltage source divided by the total reactance. That's going to give us the current. So for this example, what does that actually look like? We've got two capacitors in series, therefore we use the capacitor series law. So that's going to be XC1 plus XC2, and that's going to give us our final XC total. And that's going to be 100 ohms plus 200 ohms, which is equal 300 ohms. Now how does this circuit look like? So here's the final circuit. What I've done is summed both capacitors up and combined it to equal 1. Now we've got the same voltage source, and therefore we can say the current in the circuit, which is IC, is equal to the final voltage VC over XC, which is 100 volts divided by 300 ohms, and that's going to equal 1/3 of an amp, which is 0.33 amps, rounded to 2 decimal places. Now let's step it up. So here we've got another circuit which is with two capacitors in series. So to calculate our final reactance of the circuit, XCT, that's going to equal the reciprocal of each capacitor, which is 1 over 100 plus 1 over 200. Then again we take the final summation and we take the reciprocal again. So what does that equal? 66.67 ohms, rounded to 2 decimal places. And then finally the current in the circuit, IC, we use the same equation, so therefore we can say that the current going through the first capacitor is going to equal the voltage in the parallel. Remember, the voltage is the same, divided by the total reactance 1, which is 100, divided by 100, which is 1 amp. And therefore we can say IXC2 is equal to voltage all over XC2. That's going to be 100 all over 200, which is 0.5 amps. And remember, the total current in the circuit must equal the same, as we have the same current. So that therefore, as a check, IXC1 plus IXC2 should equal IC, and therefore 1 plus 0.5 does equal 1.5 amps. So therefore that's a check. That's our total current, and the summation of these two does equal 1.5. So that's a brilliant check. But how does the final capacitor circuit look like? So that's the final capacitor circuit. We've got a power source of 100 volts, final one capacitor with the final reactance, and a current flowing through, which is at 1.5 amps. So hopefully you've enjoyed this video. If you did, please smash the like button, please subscribe. I'll see you guys in the next video. Take care.